Hello, everyone. So I'm Darley. I work here at Avenue Code, building digital solutions for transformation, and also in the new effort to bring GenAI applications to our clients and other customers too. I have extensive experience with machine learning, classical machine learning, the new one, which is deep learning, and also data science and programming in general. So here is our agenda. It's divided in three parts. The first one, we are going to talk about the building blocks of GenAI. Then we are going to see a small use case where we can apply GenAI to create a chatbot and create a little bit of the creation of the chatbot at the end. So one important aspect of today's chatbot and GenAI in general is the concept of agents. So the agents are computers or robots in the real world, and they can take actions in the environment. So, for instance, if there is a Python program as an agent, it can access the internet and do several stuff that you can enable it to do. So they can do automation, for instance, web crawling for a particular content you want to save. They can do information retrieval, such as browse files and look into the content. Also personalized companions, for instance, Alexa and Siri, they are example of agents, and also simulations too in computer programs. The LLMs or large language models, they are kind of model that were born after the deep learn boom, and they are trained in massive data from the internet and textbooks. The thing is, they are so big and trained on so many different corpus of text that they can do several different tasks, such as text generation, machine translation, classification, summarization, and all of those particular tasks. They were not trained to do that. They simply can do it because they have lots of parameters, and this extends the capability of the model. So the difference between LLMs and agents is that LLMs are kind of the brain of an agent using GenAI. So you can have agents without LLMs. The classical way of doing it is by basically marrying usual programming in the programs with expert models, and LLMs brought to the table much more power. So LLMs can't take action. It only consumes text and generate text. And the agents, they can adapt to the environment, and they can have learning and autonomy. So LLMs can do that, but they can do a bit of reasoning and, of course, generate text. The embeddings are the backbones of several different technologies. So they are the numeric representation of the language or the image, and they are used on LLMs, semantic search, vector database, and any other different expert model you might think they can be used to. The vector database is a special kind of database to store the embeddings, which are the representation, right? So they are not like traditional SQL or any other kind of text database, because they have several different built-in functions to deal with vectors and to find vectors really quick, depending on the semantic search function. I will explain a bit more about semantic search after. So our use case is a call center chatbot. So the human person attending or answering phone calls from customers is called the operator. And then our chatbot is the agent capable of doing some tasks. So the first one is powered by the LLM, right? So it reads and writes the text from the operator. So kind of doing a chatbot conversation. And it can also interact with several different internal systems. So this is the power of the agent. The agent interacts with stuff, and it brings relevant information for the operator. So anything that might help the operator to do a particular task or to help the customer as fast as it can, that's the use case for this chatbot. So at a high level, looking at the structure where the chatbot should sit, we have several different systems. So we have the customer data platform, the order management system. These are all legacy systems, so really old. And we have billing system and other external system, external from the company, such as get the credit score for a particular customer. And all of those systems, they have uh, a special kind of interaction. So the translation layer is important for the agent to be able to communicate with those different systems. And the agent goes to each of the system and get information needed for a particular for the operator to help in a particular problem with the customer. In our case, all those systems will be mocked as text files. So we have several different text files mimicking data from each of those systems, and we are storing them in a vector database. So our chatbot is basically predefined capabilities, which basically makes the agent an agent, and the chatbot an agent, the semantic search, and the LLM. So all of those sits on top of the vector database. So the AI Studio is a collection of services that people here at Avenue Code are building. So it is cloud agnostic. It should be easy to deploy using Docker Compose, Kubernetes, and other kinds of infrastructure automation. Also modular. So as of now, we have two tools there. We have all of the LangChain ecosystem and also the Typebot. So I think yesterday, Lucas Gertels showed us a bit of the platform and also the Typebot. This image here is the Typebot, which is a tool, a visual tool to build chatbots, but it's low code. So if you need something more powerful or to do some customization, you would need to resort to LangChain and program in Python or JavaScript. For this particular chatbot we are building, we are using those tools. So Git, because the platform is hosted in our GitLab. I'm using Visual Studio Code, but you can use any other code. I also like to use Conda, and in this case Mamba, to manage the environment. We are using Poetry to install the dependencies, and Pinecone, which is a vector database, and also LangChain, because the platform is built upon a LangChain, and also OpenAI for the embeddings in the LLM. But you can use different embeddings. For instance, Fez is a free and open source version of the embeddings you can use, and also other LLMs. So this is how we can configure the platform from ground to a simple demo working. So this video is just to show how to set up the stuff. So it is real quick. So first, I'm creating here the Mamba environment using Python 3.12. So it installs everything for us. Then I'm cloning the repository. After that, activating the the environment. I'm installing Poetry because we need Poetry to manage the dependencies. So now that Poetry is installed, we have to install the dependencies, because right now the platform is Git single repository, so everything is installed there. But the idea is that this should be segregated, right? So instead of monolith, we have since it's in alpha period, after that, we are separating the packages, which are kind of the chatbots and the tools we create to use the platform. And we are placing those in a different repository. But right now, everything is in the same one. So we first need to install all the dependencies for the platform. And then for each package we create, we need to install the dependencies. So Poetry here install is to install everything. And after that, we create a template, which is a LangChain template for our chatbot. So this is what it creates. It creates a simple placeholder. For instance, here we are creating a session for ChatGPT using a system prompt, which is basically you are saying for the LLM what role it should have. So in this case, it should speak like a pirate. This is an empty template, so we are just showing how to build from nothing, to clone the repository, to have all the dependencies, and to launch and test the package we create. In this case, the package name is Tech Week. We need to add some roots because for each the package here is an endpoint. It's a REST API. So we need to create this root in the application, and we need to add the package we created as a dependency, because the platform uses those dependencies as part of all the demos and all the structure. So once we add those roots, once we add the dependency to the platform, we are good to go. So we use LangChain serve to serve all the packages and the platform itself. So here you can see the playground, which is simple stuff that LangChain does for us, so we can test if it works. So as you can see, there is Flurry, call center, and other packages. They are all built by someone and added into the Git repository. So this is the playground, and you can see that the output is the agent, the LLM, ChatGPT LLM, pretending to be a pirate. So it writes like a pirate would say, would speak, not spell. So the structure of LangChain, it's basically, we can split in three parts. So the first one is template, prompt template, which is, we have predefined templates, and we can fill it with strings, or in this case, embeddings. But the idea is that with that template, you can have programmatically created templates, and you can use it with different LLMs. And given the output of the LLM, you do some parsing. So if the LLM outputs JSON, you do JSON parsing, and you give the output. This is a RAG architecture, which is retrieval augmented generation. So given the input, if it's any kind of query, we do the transformation of this input and create the embedding representation of the query. So, for instance, in the previous example, I used hey, and I got the output from the LLM. So that word hey is mapped into the numeric representation, and this is the embedding, right? So we do the semantic search and put those embeddings through the vector database, and we collect all the documents, all the pieces of text that are uh, similar to the semantically similar to the embeddings of the query. So this is the part we do the retrieval and get all the documents we have. And the generation occurs that given this input here, and we got several kinds of documents, we put those documents, which are plain text, into the template, and we are augmenting the query or the text we pass to the LLM. So this is important because if we have several different contexts as documents, we don't want to make the LLM read all the documents because it's too expensive, and the LLM doesn't need all this information, only the most important parts. So RAG applications are important for that, or for when we don't want to fine-tune an LLM, and for when we have documents that can provide context for the query. So let's see a bit of the content here. So what I prepared is our RAG architecture for the call center, right? We are basically we need to have a few chains. So the chains in LangChain is basically that loop I showed you, that you have the prompt template, you have the LLM, and the output parse. So our chain here consists of basically two parts. The first one is the inputs. So this runnable parallel is abstraction that LangChain has to convey this idea of chains. So we can compose different kinds of chains that do different kinds of uh, processing. In this case, runnable parallel, you can have several different chains in the same runnable parallel, and they all run in parallel, as the name says. And you can also compose with Python dicts, and they become other chains. So this is a really nice abstraction that LangChain has for us. And in this case, we have the inputs separately, and we expect a question in the chat history, but the chat history here we don't use. It's just an internal variable, but it needs to be declared. And the question is what we place into the input text, right? And now the important part is the retrieval chain. So it is composed of several different pieces, right? The first one, we want to extract the username of the query. So for instance, I am the operator, and I say something like, give me data on Jane Smith, or any other kind of input. So the relevant part here is that I want to extract the name of the customer I am answering in a phone call. So we ask to ChatGPT to extract the name Jane Smith and to output it as a JSON, because uh, this avoids the hallucination. So sometimes we see the ChatGPT answering correctly, or sometimes it adds more text. And in this, I make explicit in the prompt, extract the name of the user and return as JSON. So we need the parser. So here we have all the three parts I told you before. We have the prompt, we have the LLM, and the output parser. And after that, we have the username, and we can get the user ID. The user ID is important because we have several text files which are mimicking different systems. And in some systems, you only have the ID of the user and not the username. So we need the ID. And with that ID, we can go to the vector database to get all of the different documents that mention that ID. So these are important, so we can do the RAG part, the augmentation. Not only the prompt, but we have also different kinds of parts that needs to get data from vector databases or other systems. Since we are asking for every kind of data that the system might have on the Jane Smith, we need to go through all of it and get the pieces of data. And after that, all those documents, we call it context. So those variables here are seen by the whole chain. So I'm declaring username, so the whole chain now can see username. Contexts are all the documents or the parts of the documents that are important for us, in this case, that reference somehow the Jane Smith user. And then after we get all this context, we basically ask for the LLM, the ChatGPT, to make a summary for us. And this is the final prompt. Once we have all the documents, we don't need the operator, the human operator, to read a big chunk of text, because you need to answer the call quick and solve the problem as soon as you can. So we need to summarize this really well. So this is the chain. Now for a bit of more visual stuff, so we have the question from the operator. We have all the chains here represented by this cube, and we have the extraction of the username, the user ID, and all the documents. And then the final prompt is basically getting all those documents and adding it to the string, and say, please do a summary for me, and we pass to ChatGPT, and given the output parser, we have the answer. So if we zoom in, what's happening is this. So this color here represents the prompt, this other one, the LLM, and this the parser. In the vector database is something like as a system outside of our chains. So we do a prompt to extract the name, and then we pass to ChatGPT that returns as a JSON. And with that JSON, we can parse to Python dict, extract the name, and then pass to the vector database to get the ID. With that ID, we have also several documents, so we need to filter them out. So we ask ChatGPT to filter only the ID, and then again, we have the last prompt with everything that came from the vector database and the ID, and we pass again to ChatGPT to summarize all those data, and we parse again, and we have the answer. So I can show you here. So this is the playground, so it's for us to test. So we can place here, for instance, give me the on. Okay, this. So in here, there are 8 different text files. They pretend to be different tables in different systems. And we ask the ChatGPT this whole workflow, right? And the summary here, we can ask to output in any format we want. This is just, we are as an operator, we can see the summary, and we can help the customer. So for instance, the status of the setup box is pending fulfillment, and you can ask a bit more information too. Also, we can have another LLM that outputs this information as, I don't know, as any kind of file, for instance, CSV, with the summary of everything, so we can do analysis later on. So this is the real power of those things. They build upon each other, like building blocks. So here we have all the prompts. For instance, here you can see system is what you pass to ChatGPT, so it can pretend to be some something or someone, or to have their role pre-established. In this case, so we say that the ChatGPT LLM should be an assistant that helps call center operator, and then the user is what we pass as the entity talking to the LLM, right? And we create the template. So all of these things in brackets, they are variables that it's seen between amongst the other parts of the chain. So it's kind of global in the chain. And we have several others prompt templates. And all of those templates, it's important for us to be to do a bit of prompt engineering, which is to be as clear as possible, and not to try to do several kinds of tasks at once. So we have to break into smaller prompts and to create all of those workflows. So we have we are trying to mitigate the hallucination and the variability of the prompt. So for instance, here, you can see in all those places I have ChatGPT, I'm using zero temperature because I don't want it to be creative. So it's plain as possible. And at the end, I want it to be a bit creative. So this is the kind of granular control you have.